TMI, 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 TMI.
You realize that your singing is gonna go on to YouTube, right?
Hi, YouTube. Gonna be rich and famous.
Yeah, no shit. Okay, hello everyone. Welcome to the first UML Competitive Programming Club workshop of this semester. Is there any new members? I guess maybe not. In this workshop, we'll give you a bit of introduction to the club. What do we do, all the different events that we host, and our plan for this semester, etc. We also tell you a little bit about competitive programming. What is it, and why? Why do we do competitive programming, right? And after that, James will talk briefly about an example problem for competitive programming. And then that's just to get those not yet familiar with it up to speed. And then we'll have a short break, followed by a friendly competition for everyone to join for the second half of the workshop. Right. So what is competitive programming? If anyone were to ask me that question, I'll probably tell them it's like math competition, but instead of math, it's coding, and that's pretty much what it is, right? It involves creativity, problem solving, abstract reasoning, obviously programming and other stuff, and think to be able to do well in a programming competition is more or less a proof of your programming skill. Obviously, someone who doesn't have their coding skill together wouldn't be able to do competitive programming properly. I think it's that it would just be something nice to write on your resume, right? And obviously you get to improve your coding skill quite a lot as well. So yeah, and I think even without all the other benefits that come with competitive programming, I think this is still pretty useful. Basically, you get to practice coding and you become a better programmer. You also get to learn algorithm and data structures to go above and beyond of what most people will learn in university. This is especially helpful if you want to do development in performance critical application like games, compilers, operating systems, graphics engine, game engine, system programming, and all the other exciting stuff. Most jobs that involve those skills are also paid well. I think many people underestimate the importance of the thing that you learn in competitive programming, right? Most people think that programming is all about knowing all the technology or the framework, coding APIs. But I think those things anyone can do if they learn, right? And for all the full stack development, backend, front end, other ends that you do, it's not very it's very repetitive, and from project to project, you kind of just do the same thing, right? You learn a framework, and you just use it. And because of that, they don't really pay that well either, because like most programmer can do them. But what you learn in competitive programming, I think it gives you a significant edge over other people. It makes you a scarce talent. It makes you a resource that other company wants to be a part of their employees, right? Yeah, and there's a reason why all the big tech companies have coding interview questions that are basically competitive programming questions. Competitive programming is also a good way to practice for coding interviews. Yeah, and like even if you don't end up using those algorithm and data structures in your job directly, I think being able to do competitive programming is still it will still help you a lot. It's like writing code on paper, right? Many people think, why would we do that? It's so useless. But then I think it's very important, because what it allows you to do is that allows you to write code and see the bug before relying on a debugger, right? And sometimes that's very important, because that allows you to spend most of your time on actual coding instead of debugging, right? And sometimes you don't have access to a debugger if you're writing a graphics shader. And yeah, and that skill, you can learn that in competitive programming as well. You're really under time pressure. You don't have enough time to debug your code. and so you kind of have to rely on your eyes to see the bugs. And then yeah, I think competitive programming is just very valuable in that. It just makes you a great programmer, really, and it applies as like general programming skill, right? Yeah. Another thing about competitive programming, and I think this is really about what? I'm sorry. What happened? I missed my okay. Here it is. Can you see this? But it's not showing. It's, I don't know, man. You get my point. It's a meme. Yeah. Yeah. I think this is the best thing about competitive programming and this club is that you get to socialize, right? And you not just get to socialize, right? It's not just a party where everyone's drunk and everyone's like, "Hey, bro, what's up?" But it's you meet like-minded people, right? People, not just people who are super into competitive programming, but just people who are into programming in general. We have, I think, people who are into web development, game development, designing their own programming language and writing a compiler, writing their own operating system. I'm not sure about that actually. Maybe. Right. And I think, you know, it's not just socializing, it's big brain socializing, which makes it you're like intelligent and you're like smart and super cool. So that is progress, right? It's so cool. Right. Yeah, so like I think even without all the previous benefit that I've mentioned above, you should still come to this club and you should still do competitive programming because you get to meet people who share the same interests as you do, right? And really, I think that is the most wonderful thing about this club, right? And obviously, we're not being able to do any of that now because of COVID, the damn pandemic that ruined so many people's lives. But yeah, like I think it really is a shame. I mean, in 2019 and 2020 even, we had great workshops, people coming. At the time that the club was handing out free pizza, so that, you know, now we're not having any of that. People were just eating free pizza and networking and meeting people you otherwise would have never come cross path with in your entire life. So yeah, just yeah, some great stuff. So right now, obviously, our first 3 workshop is probably all going to be online, I think. But hopefully, and I mean, I pray, fingers crossed, that this lockdown can end sometime soon and we can go back to in-person workshop for sometimes in this semester, and we can have free pizza. We can all have free pizza and all that sort of fun stuff. Right. Okay, I skipped one. Okay, it's okay. So what does this club actually do? Well, we do workshops and competitions. Most of our workshops are somewhat related to competitive programming, although we do also have some that are just related to computer science in general, like machine learning. Some of the workshops are a bit advanced, like computational geometry. Some of the other workshops are a lot more beginner friendly, like string algorithm and greedy algorithms. We also host some competitions. Yeah, we have one today, obviously, and then we also have 2 friendly competition coming up on the Friday of week 3 and 4. After that, we have a very fabulous, amazing, fantastic UML competitive programming championship, and there are prizes, right? So this is basically the chances that you get to assert your dominance over your programming peers, show them that you're better than them. It's an individual competition, and yeah, just basically tell them that you're better or you can come and have some fun. It's either way, either one works. After that, we have the reason why this club exists in the first place, the International Collier Programming Contest. This was actually the reason why this club was founded. There's a story about both of our founders did quite badly in the regional ICPC in Auckland, and then they're like, wow, we suck. Let's make a competitive programming club. So the story is actually quite moving. You can read it in the on our club's website, umcpc.org. I can type that in the chat if anyone wants. Oh yeah, James already did it. Okay. Okay. But yeah, regarding the actual competition, we will. Yeah, like this year, many things were still very unsure. Obviously, COVID bring many difficulty to the organizer of the competition. Last year, I think the divisional disappeared, right, James? We didn't have any divisional, just straight to regional.
Yeah, just straight to regionals. Yeah.
Yeah, it's all very like it's all very uncertain. But we probably choose people. We probably like organize people. We're not even choosing anyone. Anyone can come to this competition. You don't have to go through this club to go to the competition. But like we probably like ask those who did well in the UML championship, as we've done last year, to go to this competition. We'd be like, hey, you want to go to the competition? But then obviously, if you didn't do well in the championship, you can still compete. The format of the competition is that we have teams of 3 sharing 1 computer, and the contest lasts 5 hours. It's the same format as NZAC, if anyone have done that. And yeah, if you won COVID, you're first into the divisional, and then if you do well, you go to the regional. That's somewhere that's not in Melbourne, somewhere in Australia or New Zealand. And then if you do really well and you do well in the regional, then you get to go to the world final, right? And then it'll be really cool if you go to the world final. You'll probably get to meet some smartest people in the university, and make some new friends, obviously. And then if you actually win, then it will be really cool. Like you'll be world champion. You'll be world champion of the programming competition. And yeah, you probably go on to news and be really famous, and you'll be really cool. And we all look up to you. You're on bragging rights for decades to come. So exciting stuff. Exciting stuff. Right. So this is the plan for our current semester. I hope this is all correct. On week 2, which is this week, we have our current workshop, Intro to Competitive Programming. Next week, we have String Algorithm, a very beginner-friendly workshop on next week's Monday. After that, we have our first friendly competition on next week's Friday. And then we have range queries on week 4 Monday. On week 4 Friday, we have the second friendly competition. And then on week 5 Monday, we have a workshop that I host, Advanced C++, a sequel to last year's workshop, if any one of you attended that. And then on week 7, we have machine learning, which is hosted by our club president. And then on week 8, we have computational geometry. In the mid-semester break, it actually is quite late. I always wonder why they call it mid-semester. But in the semester break, we have the UMCP championship. And then after the semester break, we have greedy programming. That's our workshop so far. Could subject to change, but the first 5 is pretty much decided. Right. I want to talk very briefly about our annual general meeting. This is where we choose our next year's committee. This is how every year's committee is chosen. And if you're interested in competitive programming, you want to get more involved with the club and the community, come and run for committee position. We have 4 executive committee. They are president, vice president, treasurer, and secretary. And then we have 4 general committee. And really, anyone who wants to become committee you really get elected. There isn't that much competition in my past experience. And once you become a committee member, you get to do all sorts of cool things like hosting workshops, determining what topic is your workshop about, obviously. You can also get to write competition questions. So this year's committee is going to be writing your championship questions. Yeah, and also like just something that's really cool to write into your CV, right? Imagine you're like, I'm the secretary of UML competitive programming club. I've heard that the president from 2018 rejected an offer from Google. So, it's really cool. And yeah, so it basically it makes your resume a lot more attractive, and also the community and people and stuff, obviously. So yeah, and basically don't get afraid if you don't get elected. Like last year, I had basically no friends in the club, and somehow I magically still got elected. So there you go, right? And yeah, as I've said, yeah, if you want to be more involved with this club, come to our annual general meeting. The date for this year's AGM is 4th of October, but this could change. I think it's pretty much decided. 4th of October, you get to know more people. You get to have more pizza if you become a committee member. That is, committee member get extra pizza, and then you get to host some workshops. And yeah, that's it. I talked about all those. Right, this is mostly the end of my part. Here are some resources that were in last year's slide that I inherited. It's basically a list of places that you can go to get your to practice for competitive programming. I personally use like LeetCode a lot, but I know Codeforce is like the most widely used, the most prestigious one, and they have the most question. But obviously you can use whatever one you want. And here are some books that I'll probably put there by into 2018, and then people just never change them. But you can buy them if you really into competitive programming. Buy those books, buy it. And yeah, I think that's it for me. Now I'm gonna toss it to James, who's gonna show you an example question and basically give you an introduction to competitive programming. Right.
Hi. Yes. So I just want to get like a bit of a survey. I want to know like who isn't familiar with like the concept of time complexity, things like this. If anyone isn't too familiar with that sort of thing, just write a message in the chat. I'll try to go through this a bit slower. This section of the presentation is mostly just getting people to segue into the casual competition. So if you are a complete beginner and you don't completely follow this presentation, we have plenty of other workshops that will have the same sort of rigorousness around time complexity and things, I guess, or we'll go more in depth in time complexity and things like that. But for now, I'll just go over the process of how problems work in competitive programming. Let me just share my screen. Okay. So is everyone here more or less familiar with competitive programming? One second. Okay. Well, hopefully this all goes well. Okay. Can everyone see my screen? Richard, can you see my screen? Yep. Okay. Cool. Let me know if there are any messages in chat, Richard, because I cannot see the chat currently. But yeah. Okay. So first, keeping up to date. We have a couple of websites that we're on. I'm sure you're all on the Discord already if you saw this. But if you're not, there's a link here and we'll post it in the chat a bit later. And then there's also our Facebook pages, which we'll also post a bit later. Now, the competition is no longer on Spodge. It was going to be hosted on Spodge, but a couple of issues arose. So the last 20 minutes or so, I'm going to be dedicating to signing everyone up to the Judge site. So I'll direct you all to a Discord channel or into the Zoom channel, put in your usernames, and then I'll send you a private message with your login for the competition. Okay, but how do you compete in competitive programming? First step, document. Okay, now in competitive programming, you're given a problem statement and you're asked to translate some input into an output, like most programming. Let's have a look at an example problem statement. So this is a very simple problem. Alice wants you to multiply two integers a and b. Write a program to help her. So this is the first part. The statement is the problem statement. It outlines everything that the problem wants you to calculate, any details of the problem. Now the second part is the input, or the input statement. So this is what you're given into your standard input. In this case, you'll receive two space-separated integers a and b, which means in Python, to get from standard input, you use the input function. And in there, you will get a string with an integer, then a space, and then another integer, representing a and then b. And then your output statement is what you need to print out. In this case, a single integer, a multiplied by b. And finally, there's the constraints section. Usually this is bounding like the size of lists, things like that. But there can be some weird constraints, like maybe you have two lists, one size n, one times m, and they're bounded by n times m, or something like that. Or the number of edges in a graph is bounded by, I don't know, some k or something like that. Not very important. In this case, the constraint is a is less than a billion, b is less than a billion, and they're both positive. So how can we write an example program for this? Well, here's some example Python code. We take in the input first as a string with the input function, then we split it up by spaces. So we split those two space separated integers, and then we convert the first one into an integer, and we convert the second one into an integer and assign them to a and b respectively, and then we print out the multiplication. And there are more concise ways to do this. For example, if you split a list, you can use the map function to map each item in a list into an integer. And so you can see this is a bit more concise Python code if you're writing for that problem. And C++ is pretty similar. You just have some boilerplate code, use the input-output stream, define true long longs, which is important because a times b could be up to 10 to the 18. Which does not fit within just a normal integer. So you read in a and b, and then you output the multiplication. Okay, so what's important is that your solution has to run fast in competitive programming. Now this competition is more aimed towards beginners, medium. There's 3 problems for an hour, and I'm sure the experienced among you will get through it quite quickly. Maybe the last question will take some number of minutes. But what does it mean to run fast? Well, it means you have to do it within the time limit, in the case of competitive programming. But there is a way to measure that, and that's through algorithmic complexity. So were there any people who were unfamiliar with algorithmic complexity, Richard, in the chat, or? Okay. Well, that's good. We can sort of go a bit faster through this. But here, let's take the same problem, but let's do a pretty terrible approach to this problem. Oh, that's not updated. But okay, let's do a pretty terrible approach to this problem. And instead of just doing a times b, which is a constant time operation, very quick, you can calculate it instantly, practically. Let's take in a and b as our input, and to multiply them, we will add to ants b times. That's supposed to be ants plus equals a, but I stuffed that up a little. That's fine. Yes. Now, what is the complexity of this? Well, you can see in this for loop, we're doing roughly B additions. We're adding B times. And so the complexity becomes O of B. Yeah, below we do B additions. So it becomes roughly O of B complexity. Well, it is O of B complexity. And for a formal definition of what big O is, we say that in a complicated way, more or less, if something is O of n, then if you have an equation which represents the time complexity of your algorithm, how many calculations it does, it's O of n if it's less than some constant times n. And as n approaches infinity, it will be bounded by n, c times n, some constant times n. But what does that really mean? It just means the complexity of an algorithm is how fast it grows, not depending on constant factors, not depending on the coefficients. Okay, this is important for competitive programming because it's a great way to get an estimation of how fast your program will run. Most of the time, you'll have a time limit for your problem and it'll need to run in a second or 10 seconds, something like that. And so if you're doing O of n calculations, Python can do roughly 10 to the 6 calculations in a second. And so if your algorithm is O of n, you can handle an input of size 10 to the 6, 1 million. And C and C++ are a bit faster. Java is roughly the same as C and C++, but a bit below, maybe 10 to the 7. So what's a rough idea of what time complexity you can have for each of these languages? Well, if n equals 7, you can probably fit in around n factorial. O of n factorial complexity. If n equals 20, you can roughly do O of 2 to the n complexity. If n is 1000, you can probably do O of n squared. 10,000, you can do n square root n. 100,000 is n log n. And 1 million, you can do roughly O of n in Python. So you'll probably see quite commonly complexities like n log n, n log squared n, O of n. Maybe not too often you will get O of n factorial or O of n square root n, but they are there. So it is an option. And in C and C++ and Java, these numbers are buffed a little. So you can handle around 100 million for O of n algorithms, 1 million for O of n log n, 100,000 for n squared, and so on. Okay. I think you're all pretty familiar with time complexity already, but for the shy of you, here is an example of something that's O of n squared, if you were wondering, what does something that's O of n squared look like? So let's say we get some input, n, then we loop n times, and for each loop, we do an O of n calculation with that other for loop inside of it. And so what happens is the first time we run the loop, we do n calculations. Next time we do n calculations. And then we do that n times. In total, we get n times n calculations, roughly. Some constant times n times n. Oh. Yep, that's basically the end of my presentation. We're not signing up on Splodge anymore. If you are not on the Discord, then can you please drop just a username in the chat on Zoom? Actually, we'll just make it all on Zoom. Can you drop a username if you want to compete in the competition today? Very casual competitions, competition 3 problems, 1 hour, just to get started with competitive programming.